Hello, this is Mr. Crouch here at the Rankin campus. We're down in the first year shop. I'm going to go over a demonstration on how to install gauges on a Type 2 piece of equipment per the EPA recommended way. A few first things here though, we need to make sure we have our proper safety gear, first being our gloves, our glasses of course, and then as far as tools to install and remove gauges, we're going to need a tank of the same refrigerant that's in the system. This particular one has 134A in it. Additionally, we're going to need some wrenches. Use a couple of adjustable wrenches. A service valve wrench, because this particular unit has some two-way service valves on it. That's the 4-position valve. And we also need a set of gauges. The gauges we're going to use here are the Testo 557s, which are issued in our tool issue. And we're going to go through all the steps required to install and remove the gauges. Okay, our first step here in getting our gauges installed is going to be obtaining a tank of the same refrigerant that's in the system. This system has R134A in it. I've obtained a .39 cylinder. This is a one-time use cylinder. If you're using a recovery cylinder, it's very important that you verify the refrigerant that says it's in it is actually in it. And that's simply done by doing a temperature pressure test on the tank, the recovery cylinder, and getting a temperature around the tank itself. So we'll skip a few steps on that since we have this .39. So we have our .39 cylinder, matches what's in our system here. This would be considered a Type 2 system per the EPA because we have permanent access valves on it, and therefore that qualifies it as a Type 2. So our first step in getting our gauges installed is we need to verify that both valves, these two-way service valves, are in a position that it's safe for us to remove the service caps and install our hoses. So how we're going to do that is we're going to remove the stem cap that is on each of the service ports. The first one I'm working on here is the one that's located on our receiver tank. The second one here is going to be on our suction line attached to our compressor. So what we're going to do is with those caps removed is we're going to use our service wrench, and we want to make sure that both of these valves are in the back seat position. And in doing that, we need to make sure they are 100% counterclockwise. So I'll just get on the stem there, make sure I'm 100% counterclockwise. Suction valve is, now I'll come to the receiver valve, also 100% counterclockwise. By both of these being in the back seat position, I now know it's safe to remove each of these service caps and refrigerant will not come spewing out. I'll go ahead and pop those caps off. This particular unit has service caps on it that have a flat edge, meaning that they were designed to use with a service wrench. Some of the ones you may find out there are going to have a knurled edge on them, and those are ones that you can typically undo with your hand, maybe a pair of pliers if needed. Set those in a safe spot. Now with both valves verified on position, I have my service caps off. I'm going to go ahead and take my gauge hoses. First we'll do our red hose. You can do the blue hose first. Not too important on the order at this point. And we're just going to screw them on there loosely. And by loosely I mean I usually go about finger tight and then back them off a full turn, enough that I can still pivot them in there. That's typically pretty loose right there. I'll go ahead and get my low side hose, which is blue, and connect it to the suction valve the exact same way. Also loose on there. Next, with my manifold, I'm going to use the yellow 1/4 inch OD hose. I'm going to connect that to my refrigerant cylinder. This connection, unlike the loose connection here and the loose connection here, the connection on the tank, we're going to go ahead and snug that down. Now with that snug down, our next step is we need to verify that our gauge manifold hand wheels are all closed. So in order for it to be closed, my red, which goes to the high side, needs to be 100% clockwise. My blue, also 100% clockwise. Now with the Testo 557, we have 4 hoses versus a traditional 3 hose. On the larger 3/8 hose, we're just gonna leave that closed. And even in your kit, you'll find it comes with a 3/8 cap. Typically, in most cases, we'll just leave that cap on there and not even have the hose connected until we get to doing something such as an evacuation, is where that larger 3/8 hose will come into play. So we'll have the larger 3/8 hand wheel 100% clockwise. Now when we come down to the yellow hose hand valve that's located onto the tank, we're going to open that one 100% counterclockwise. We want to be able to have flow go through that valve up to these hand wheels, and eventually we're going to use those hand wheels to remove any air and moisture that's in our hoses. Currently they're sitting at atmospheric pressure, so we're going to use the pressure from the tank to force any air and moisture out of our hoses up to the yellow hose, and then we'll open the accordion hand wheel to force it on out through our blue and also red hoses. It's very important that we get all the air and moisture out of the system because if we have it in there and mixed with the refrigerant, it can become a contaminant and turn into an acid that will eat away at the internals of the compressor. So first step here, I've verified my hose connections are loose. Both of my hand wheels are closed with the exception of the yellow hand wheel for the yellow hose. It is open. From here, I'm going to go ahead and open the valve on my tank. Approximately 2 turns is plenty. We just want to allow the pressure to get out of here. So in my next step, I'm going to loosen the yellow hose at its connection at the manifold. And we're going to allow just vapor refrigerant to bleed out of here. We're going to do 1 second of a bleed per foot of hose that we have. This hose here is 60 inches or 5 foot, so therefore it will require a 5-second bleed on there to remove any air and moisture. So we'll go ahead and we'll loosen that up. Count 1, 2, 3, 4, 5, and tighten it back up. So now we've used the positive pressure of the tank to push the air and moisture out of the hose up to the manifold. Now by manipulating my blue or red hand wheel that controls pressure going to either the blue or red hose, we're going to use that same tank pressure to push the air and moisture out of the hoses up to where the gauge port is. We'll go ahead, we'll do the red hose first. Again, this is a point where it doesn't matter particular which order you do the red or blue in, just as long as we do the both of them. 1, 2, 3, 4, 5. Very important that we tighten it first and then we close the hand wheel back clockwise. If I were to do those 2 steps out of order, I would lose the positive pressure that I have on my gauges. Moving forward to the blue hose, same deal. 1, 2, 3, 4, 5. We'll tighten and then close. At this point now, I have the same tank pressure in my yellow hose and both my red and blue hoses. I'm going to have my gauge manifold turned on. I've already have it set at R134A, and I've already zeroed out the gauges. So now at this point, they should be reading a pressure of what was on the tank, since I've introduced it now through the yellow hose and both the red and blue hose. It's showing me that I have about 65 psig of pressure that was in this tank, which should follow right in line. If I were to use a PT chart, look at the refrigerant, compare it to this pressure, it would actually act as an indicator as far as what the temperature is that this tank has been stored at. Pretty neat little trick to use with the PT chart. So moving forward now, I've got all my hoses pressurized with positive pressure. I've got all the air and moisture bled out of those. And now I'm going to go ahead and open up both of my service valves. Just introduce that pressure to the system, or whichever pressure is higher, so I can read it on my gauge. In order to do that, we can start with our high side valve that's located on our receiver tank. And we need to turn it clockwise, just a quarter to a full turn. Now that's put this valve into the cracked off the back seat position, which is used for taking and reading pressures on a running system or one that's sitting idle as here. We'll do the same thing with our suction valve. And now I have pressure from the system being read at the gauges. I had this system running a little bit earlier just to verify everything was okay on it. So we still have a bit of a temperature and pressure differential there between the high side and the low side. With that being said, if it were a system that had been sitting here for a while, those pressures would have equalized and be reading both the same right now because the compressor is not running. So moving forward now, I've got my gauges hooked up, all my hoses are bled. Both of my valves are in the cracked off the back seat position. My tank is roughly about 1 to 2 turns open, but not allowing pressure to go through the manifold anymore because both my blue and red hand wheels are closed. So it would be safe to turn the system on now. And as it turns on, we should see the compressor and the metering device doing their job and creating a temperature pressure differential or dividing that high side and low side. From this point, we could move forward in doing some checks on the system. Now that our gauges are installed, if we needed to do any other procedures, such as a recovery, or maybe we needed to add refrigerant, they could all be done from this point now that we have our gauges installed correctly. Next class, we're going to be going through and doing a demonstration on the removal of a set of gauges per the EPA recommended procedures on a Type 2 appliance. Our first step in gauge removal is going to be closing the tank valve. We need to turn it clockwise 100%. Next, now that the system is running, I'll just cycle off, is we still have, because our high side hose is connected to the liquid line here, we're still going to have an abundance of liquid refrigerant in there. And the reason we want to go through our next steps in this procedure is we want to eliminate losing that liquid refrigerant into the atmosphere for 2 reasons. 1, it's going to affect the charge on the system, and 2, it's really not good for the environment. So our first step after we've closed the tank 100% clockwise is we're going to backseat the high side service valve that's located on the receiver. What this is going to do is close off all flow going to our gauge manifold, and we turn this clock counterclockwise in order to get to the back seat position. And now that I've got this high side valve closed, I still have my suction valve closed or open. So in order to get that refrigerant out, we're going to do a procedure that's called bypassing. The bypassing procedure is simply going to use the difference of high pressure goes to low. We're going to open up our hand wheel for our high side hose, and we're going to open up our hand wheel for our low side hose. We're going to do it a little bit at a time and in a sense act like the metering device. We're going to get the low side pressure to draw in the high side liquid back into the system before we remove our gauge hoses. In doing so, we'll go ahead and open our high side hand wheel. I like to open it at 100%. Now with the low side hand wheel, this one I'm just going to crack open a little bit at a time. So we'll turn it counterclockwise and then back to clockwise 100%, a little bit at a time. We don't want to throw any liquid at this compressor, So doing it in small amounts, it will flash off in our hose as it goes to the lower pressure. And we're going to do this until both our high side pressure and low side pressure are at an equal amount. Currently I've got about 31 and 43, so I've still got a little bit of high pressure in the high side. We'll continue to bypass. Until both sides are showing the same amount. When they're both showing the same amount as now, that tells me that all the liquid has boiled off into a vapor and it has the same pressure as what's on my low side hose. Now it's okay to go ahead and put my suction valve in the back seat position also. We'll turn that counterclockwise. And the whole time I was doing the bypass, it's very important that the compressor is running. Again, if the compressor's not creating that temperature pressure differential, we're not going to have a difference in pressure from high to low, and our high pressure would not go to the low side. So sometimes, just as I did here, you may have to open up the door on the unit in order to get it to stay running. Currently looking at the pressures, they are still both equalized and staying the same. I'm going to go ahead and turn my high side hand wheel back 100% clockwise or close it. I'm going to do the same on my low side one. We can turn the unit off, and we're going to remove our gauge hoses now. As you do so, you may do it slowly, just to allow any pressure that may be trapped in there. Also the low side, a little hiss. And now our hoses are removed. It's safe now to go ahead and put all of our service caps back on. And we want to make sure that they're tightened down using a wrench. Some of these two-way service valves, the stem has a tendency to leak some, so it's important that we get the caps on secure and tight to prevent any refrigerant from leaking out of the system. While we're talking about the valves, one thing I would like to note is when we were doing the bypass and allowing that high pressure refrigerant to go through the manifold from the red hose to the low side of the system through the blue hose, sometimes you may run into an issue where you're unable to get the pressures to equalize. If that's the case, you may have to go back and check that your adjusting stem on the high side service valve is in fact 100% counterclockwise or back seated. They have a tendency over being used sometimes. They get a little worn out. There's a little Teflon seal in there and they can leak past. So sometimes you might need to get them a little bit more tighter than you had them the time before. And that would be our gauge install and removal.